Lesson 12, implementing host security solutions. So we're going to talk about some firmware upgrades that we need to do, making sure our endpoints on our desktops, our laptops are secure. And we're also going to talk about embedded systems when it comes to security for them. So we're going to start off with the first thing that happens whenever you hit the power button on your laptop or whatever device that you're trying to boot up. It goes through a checklist to make sure that the hardware that is connecting to is all authentic. And we call this the root of trust. So with every manufacturer, whenever they put a motherboard together, you want to make sure that everything is what is there that's supposed to be there, and nothing is foreign to implementation. So in order to make sure that every hack is not done software wise, it may come down to someone putting some extra chip on your motherboard in order to route back traffic or information. So we want to make sure that the root of trust is checked and make sure that it is a up to date when it comes to the firmware side of things, and making sure that it stays secure. So whenever we do boot up our systems, we can see if anything has changed. So what I want you guys to understand is that we do have different ways that we can boot into our systems. We can use a secure boot and a measure boot. And while these things are important, is rarely used in the real world. What I want you to really focus in on, and when it comes to your firmware or your secure boot, is getting to your firmware, making sure that it's up to date. Just in case when we're running regular operations and security, sometimes we may see how a manufacturer says, hey, we have put an update out for the firmware on these different devices, and we just might have those devices in our network. So we want to make sure that we can get to that boot up page and update those firmware as much as possible, because a lot of times the firmware page is so quick to where we really don't think about updating it or making sure that it's secure. We just go right to our OS. So I want you guys to really make sure that you keep an eye out for any type of vendor update. Keep an eye out for firmware updates, and making sure that you can get to your firmware page and then upload the latest update. Now, in some cases, you'll see where IT departments secure and encrypt the whole hard drive that's on a device. And while this is good, it also serves some problems when it comes to efficiency, when it comes to workload, or someone setting up the laptop really in a quick situation and then having to log in once for the encryption of the hard drive, and then log in twice to actually get into the PC, and maybe log in again to get to the VPN. So you can see how this can be cumbersome. But when we're talking about very sensitive information, encryption of the whole hard drive could be a thing that we want to do, just in case we're doing a lot of traveling. Let's say we're working for the government and we encrypt that hard drive because we're going to a lot of out of the country places. And let's say if we leave the laptop on a plane, now if it's unencrypted, then someone can run a password cracker on the login screen, hopefully get in, and then look at all the information that we have there. But if it's encrypted from the hard drive standpoint, then they have to know that password first in order to get the keys, in order to unlock that encryption to get into it. So as we working in the security department or IT, we're going to deal with a lot of vendors. There's no way around it unless you just have everyone that really kind of does everything in your shop. But more than likely, you're going to probably have to go out and seek additional help via a vendor or a third party. And the thing that we want to remember when it comes to Security Plus is that what types of risks do they bring into our environment? So do they practice the same security practices that we do? Because they may put in maintenance hooks and then come in at a odd hour at night in order to perform their tasks, or they may not use a VPN connection when it comes to remoting into your network. And so if we want their services, we need to make sure our interview processes are well thought out and we understand what type of risks are we taking on when we're bringing on this cloud company, let's say. And let's say the cloud company does not have a backup to their backups, right? And so let's say, you know, the worst happens and they get hit with a natural disaster. Now their data center's down, your information is lost, and they don't have a way of getting back up. Now that impacts your business because you're waiting on your cloud supporter to get back up. And so that's a risk that you have to factor in and you have to take account for, that if um, our data is unavailable because vendor A is not available, what do we do? How do we suffice for that? How big of a risk should we want to take on that? And those are the type of things that we want to consider when, we're bringing in different outside services into our network. I think a lot of the things that we see on a normal basis is out of life systems and the lack of support when it comes to those end of life systems. A lot of places that I've been, they either are holding on to old software that's no longer supported. Maybe the company's not in business anymore, or they've been doing things so long in this way that they're not looking to upgrade or see a better way of doing things. The first thing that comes to my mind is when you go to a car dealership and they have the old inkjet printers, and it's doing the carbon side of paper, and it's printing like that. And I always wonder, why wouldn't a company just go to a inkjet a regular printer that just prints out the regular paper? Now maybe it's the regulations that's holding them back. Maybe they don't have the money to upgrade into a higher standard, but it's when that old type of printer breaks, who's going to be able to support that? Who's going to be able to get you parts for that printer? Who's able to get you ink for that printer, for that matter, or paper? So it kind of leaves you in a bind when it comes to actually running your business. Do you have the materials to actually run your business? Now, when it comes to end of life, when it comes to software, PC wise, I see a lot of people who have Windows 7 XP, Windows 8 in their environment, and they're not they may not be in a position to buy the latest software, but they also may have employees who don't know how to work with the new software. So now the training comes into play, and you may lose production because we have to step back and train everyone again in order to work on this new system. So just be aware of that when working in the security field, that we want to push our latest and greatest out. But at the same time, we need to keep in mind that everyone is not ready to make the leap, the jump, and everybody's not trained to do so. So we need to make sure that our declining software is up to date as much as possible, but we also need to give them a deadline that, hey, we cannot go into a point where this is no longer supported. It's end of life. We must be gone by this date, and we must have people moved over. It's only this type of advice is only going to keep the business moving forward. So when you're doing that, vetting out that process of bringing on a third party into your network, you want to make sure that you understand some of the agreements that we have in order to keep them honest and put everybody on the same level when it's time for them to provide a service to you. So you want to make sure you have a memorandum of understanding, a MOU. If you're dealing with something secretive, or we have some type of trade secrets, or we have some information that we don't want disclosed to the public, we may want to have a NDA. And that NDA, you have them sign it, and then we can give them the information of what we do on a daily basis. So if we have our competitors all of a sudden know our ingredients to our secret cookies, then we could say, hey, it was probably these vendors who we've been interviewing in order to know this type of information. Now, you also want to know about the service level agreement. What type of services are they going to provide, and what time frame are they going to provide it? So if we use them for a call center actions, is it going to be 24 hours? How long would they respond to an emergency? Things like that. We can all be on the same level of understanding when it comes to what they're actually bringing to the table. So creating a host hardening process is usually comes with taking off applications that we don't necessarily use, only giving permissions where necessary, and making sure that we we reduce the attack area for the attacker as much as possible. And what I mean by that is that we are just not giving our users the desktop or laptop straight out of the box and everything is enabled and they can do whatever they want. That's a good way of having a large landscape of things that a hacker could go in and take advantage of, such as Bluetooth, or certain ports may be open. We may have applications that we never use on our laptop that may become vulnerable because of end of life just happened for that company that's not in style anymore, and we haven't changed that application because for whatever reason, and so we haven't did a rollout to actually roll back that application and take it off people's machines, and so it's just sitting there, just not bothering anyone. But if someone was to get into the network, get onto that host and see that application, then they can say, oh, you know what, that host has been vulnerable for such and such. Let's take advantage of that and see what we can get. That's what, we can eliminate by having a hardening process. We have a checklist of things that we want to go through and make sure that we manipulate on our devices to make sure that we close down the things that we don't need, making sure that it becomes a harder attack vector for the hacker. Now, to kind of go into different types of software and different configuration factors that we want to go into that hardening process, is having a baseline of configurations, and also when it comes to the registry too. We can use software that keeps a baseline of applications on our network. These softwares, they look at everyone that's on the network and they see if you added a application or some type of let's say code or a different type of agent onto your machine, that it could roll back unto a known good state and say, hey, it uninstalled that application that you installed yesterday because that's not our baseline. And in order to keep things on a level playing field and to make sure that no one is bringing in new attack vectors, I'm going to roll back to our baseline configuration, and you're going to start doing your work today because I've given you everything that you need to do your job. Another important part about host management is making sure that we have patch management. So think about every device that we have on the network needs to be patched and updated with the latest firmware, as well as OS patches and application patches, pretty much monthly, on a monthly basis. And so making sure all these things are up to date, and that we're not introducing any type of vulnerabilities because of the lack of patching is very important. Now, when you think of patching, I want you to think these are known vulnerabilities that are looking to be fixed through patches. When Microsoft gives you the warning and says, hey, it's time to patch your machine or update your machine, it's saying to you, hey, we noticed that there's something bad with your machine to where a hacker could take advantage of and get information from you. Please apply this update, and that will solve that issue. That happens on a monthly basis. Now, to your knowledge, we will always have patches. There will be no end to that. OSs is millions and millions of codes, lines of code, and so there's a good chance that someone's going to catch something every month if we have enough eyes to look at it. And so that's why we have different types of vulnerabilities coming out. That's why we have different patches coming out. But it's our jobs as security professionals to make sure that we patch those devices as quick as possible. Now, you heard me talk about some agents that we could put on our desktop or our laptop, and those agents talk back to some type of console in order to bring a service. In this case of hardening or keeping our endpoints protected, we want to make sure that we have antivirus malware protection on our PCs, and 9 times out of 10 that they're going to probably do a IDS and a IPS function. So remember, IDS is intrusion detection, and IPS is intrusion prevention system. And so these the antivirus will be able to detect, and it's also be able to prevent by blocking the virus. Right now, we also want to have something kind of like a DLP agent where it will see if any sensitive information is leaving our laptop, and we want to make sure that it can be put in place too to detect it as well as prevent it from actually happening. So having these endpoint agents on our PCs is probably something that we want to put into our baseline configurations, and making sure that they are up to date as well. So all these things we want to take into consideration when it comes to having patches and making sure that we are protected overall when doing our daily tasks. Now, as antivirus has evolved over the years, it still is lackluster in some type of way of actually containing a spread or a outbreak of a virus. So we have these things called EDR protections, and this is where we have more functionality when when it comes to an attack, and we can actually isolate devices on our network from being contacted from any other devices. So whenever our SOC, our security operations center, they contact us and say, hey, PC 123 is actually showing signs of this, that, and the third, we can use our EDR system to isolate it, basically kind of put it in its own silo within the network. Therefore, it cannot reach out to other PCs and affect them, but we can have a secure connection only to that PC in order to see what's going on with it and see if we can eradicate the problem before it gets out of control. So when we're talking about antivirus, more likely we're going to talk about a signature-based software that's going to download code that's similar to the malware that came onto the computer or would be coming onto the computer. They take this database that they download, these signatures, and they compare it to whatever files that you download or you add to your system. And then if they match, then they will flag it as a virus and quarantine it or delete it altogether. So this is what we mean by signature-based antivirus. Now, heuristic is getting a baseline to what's normal, and then anything that's abnormal, we will flag it as being malicious. We need to also be aware of embedded systems. These are things that could be low-powered Internet of Things, things that we could just plug into our PC and maybe get some extra functionality out of them. I like to think of a smartwatch or kind of like a, not necessarily an Apple Watch because that has a lot of functionality, but let's say like a Garmin watch or a Fitbit. These kind of embedded systems, they can get attached to our network and then maybe transfer some things back and forth. So we need to be mindful of those and see if we need to actually put on more security by locking down our USB ports and not allowing them to connect to our end devices. Now, in the cities, you have these industrial control centers or systems, and these are things that's in place that's controlling some type of, let's say, water system that the city uses to give everyone a clean system of water. Now, these systems that control these mechanic operations, they are not your typical, Windows 11 or latest iOS product. It is a old operating system that can't take any type of update. There hasn't been any code to update them. When you think about it, in order to update them, we need to cut off the system that is supplying everyone in the city or town or what have you, and then upgrade that system. So it's kind of a catch-22 where we can't really do anything with them. So what we do is we will focus more on a physical side of security to make sure everyone doesn't have access to the system, making sure that it's in a secluded area and that is well off secured physically wise in order for someone not to be able to get control of these systems and do any kind of harm. So like I mentioned with the water system, these systems also goes into, energy power plants, industrial, different types of facilities and logistic facilities. And can you imagine if someone were to get their hands on a system that could pollute the water that you and I drink? And there's nothing that we can see from it because we don't have those systems connected to the internet. So it's not going to give us a warning like that. We have to kind of just wait for the disaster to happen and actually react to it. But, in this case, we want to make sure that we take the precautions to, stop that before it actually happens. That's why we want to focus so much more on who has access to these systems and making sure that we vet them out. So I kind of touched on the Internet of Things earlier with the embedded systems, but just to kind of dive deeper into that, Internet of Things could be anything that connects to the internet and then desires some type of communication. And that could be, when you go to Lowe's and you see that new smart refrigerator that can connect to the internet and give you the morning page of the New York Times, and it can tell you what's in the refrigerator from whatever spot that you're at, because it can communicate to the router and the router can communicate to your cell phone while you're out in traffic. Well, it's so many things that's actually taking that type of characteristic where it needs to talk to the internet. As soon as you open it out of the box, it's looking for a Wi-Fi signal. And we have to be, as security professionals, we have to be aware of this coming into our network. We can bring things in from home and connect to our work internet. And now, from without your knowledge, you're letting another vector for a hacker to possibly get into, where we have everyone's wearing Apple Watches now, or we have some type of iPad that we're bringing into work, and these things need internet connection. I know the password for the enterprise network. I'm gonna just put it in and go ahead and connect my device so I can stay up to date. But like I said, these things bring in vulnerabilities also, because if we really think about it, who's actually have a up-to-date iPad or Apple Watch, or even headphones for that matter? And are we teaching our users to update these things before they actually bring them in and connect to our network? So other endpoints that we may have is different types of products that we actually need to do business. And I talked a little bit about how car dealerships had old printers that needed to, print on old carbon paper. And those printers, 9 times out of 10, are sitting on the network. We also have VoIP phones that are voice over IP, using those as telephone devices. So we have different um, devices that we have not only with our iPads and our device laptops, we also have different types of keypads that we may use in order to give extra functionality to our actual business. But the thing with that is that we want to take those things into consideration when it comes to security. Yes, your laptop is secure, but what about the keypad that we use for our customers to actually key in their social security number or key in their PIN number to their bank card? Have we updated the software on the keypad? Have we updated the software on our phones? And making sure that no one could see the traffic coming in and out of that. In today's world, we're doing more things with cameras, and those cameras are able to upload the video directly to the internet or to your favorite social media site as soon as you hit stop. So those things, again, they connect to the internet, and then they're able to send traffic out as soon as possible. And we also have this thing where drones are giving they're shooting footage, and then they're able to send it to whatever cloud provider that they may be connected to. And all these things are great for functionality. They're great for the studio, and they bring that extra efficiency to work. But when it comes to a security side of it, and it comes to someone looking into hacking your network, these are open vulnerabilities flying around in the sky. And then, if we forget to patch those things, or we forget to change the default passwords on those devices, then we stand a chance of being compromised just by having extra functionality in our workforce. One field that we don't want to overlook is the medical field when it comes to different types of devices and what they can do, from everything from thermometers to heart pacemakers, I'm sorry, or ear aids. These are different devices that could be have embedded systems in them, or they can be so smart to where they want to talk on the internet. And so we need to make sure that, especially in the medical field, that we take accountability of these things, because we don't want different devices going into surgery and having a chance of, soon as it hasn't been turned on in so many months because it's not necessarily used on a daily basis, but since we have this surgery today, we're going to use this type of device. And now once it turns on and someone's they're getting ready to have surgery, and now it goes into a reboot because it's updating automatically. We need to make sure that we have those things already ready to go. We taking accountability of these devices, and that we have them ready to go to avoid situations like that. So like I've been saying before through this whole class, is that we want to make sure that we take accountability of them and know that they need to be patched at some point in time, or to make sure that we are up to date, and maybe they don't need to be patched for the next 4 years. But it's the fact that we're at a point now to where we know what firmware that needs to be updated, or if it's good to go for the next however time. And we probably need to check these things on a quarterly basis, every 3 months, and make sure that nobody's came out with a new update. And if you're talking about a OS, a normal operating system, we want to make sure we patch those things on a monthly basis. Or if not, if it's severe enough, we probably want to patch those things as soon as we learn about the patch. Okay, so just making sure that we take an accountability of those embedded systems, because again, those are gateways that we may not be aware of coming into our network. So the key points to review. In this lesson, we went over firmware and we went over patches. That's mainly what we went over and over in each slide. But it was also, we also touched on endpoint security when it came to our devices. What things do we bring into the network? How can these things communicate with our routers and our other devices that we have on the network? How do we provide security for those things? And for most cases, having a patch for them is probably our best choice to have them patched and up to date could be our best choice when it comes to providing security for our endpoints. So lesson 13, start talking about secure mobile solutions. How do we put mobile devices in our network? How do we make sure they're secure as possible? And how do we manage those products? When it comes to the Security Plus, you want to know this about mobile devices is the deployment models. And the most popular one to be familiar with will be bring your own device. And that's when your employer is going to allow you to bring in whatever mobile phone and mobile phone carrier who you're with. And you're able to take that device and then connect to the internal network. And so we already went over how important the internal network is, but now for me to let you bring in a outside device and put it onto our network, I'm opening myself up to any kind of vulnerabilities that you may have on your device. So you have some places that go about this model because it cuts costs, right? But some others may issue you a phone. They may tell you to choose your own phone. So they may have different carriers and they tell you to pick between an Android or iPhone or what have you. So different types of deployment models, but the one that we really want to focus in on is bring your own device. That's the one that poses the biggest risk, in my opinion. Being able to let you just bring in whatever phone that you have, and now you can open up business documents on your phone. Now, whenever we're introducing mobile devices, we want to have some type of management system that can control the type of applications that we have on there, what type of patches that we want to push out. We want to have some type of system to say, hey, we want either a code that you put in, so like a PIN number, or do we want you to put in a pattern, or do we want you to use biometrics? We want you to use facial recognition to unlock the phone, what have you. So we want to make sure that we have these systems in place that we can manage our phones from a remote spot. Also, if you're going on a, let's say, a trip and you have your business phone with you, this management system can have the ability to remote wipe any type of phone, or the phone that we're actually issued out. We can remote wipe just in case one of our clients, our users, loses that phone for whatever reason. We can send a signal to it, so instead of someone hacking into it, we can remote wipe that phone out. So this brings us to the different types of phones that we have to really choose from, and it's going to be between Android and iOS. Here we see how Microsoft Azure is actually controlling the Apple OS environment within our network. So a lot of times you'll see a Windows shop, and when I mean Windows shop, meaning a business that's fully Windows, or they're heavily Windows with some MacBooks maybe sprinkled throughout, but they're heavily Windows, and yet the mobile the side of it is heavily Apple. So it's kind of funny to me how the mobile side of the industry is strictly Apple, but yet when it comes to desktops and PCs and servers, we're probably more heavy on the Windows side. But anyway, Microsoft Azure is actually controlling or managing the Apple phones that we have on this network. And this is a good way of saying what type of applications do you want on your phones, your customers' phones. What type of patches do we want to make sure that they see and that they actually get notice about, so they can actually apply those things. So having that controllability from a IT standpoint is something that we can do to control that security standpoint when it comes to the mobile devices. Now, what I forgot to mention is that, for the most part, Apple, the iOS system is very good with having people getting applications from the App Store. Um, where, on the other hand, in the Android community, is not necessarily as, I want to say, as secure to get a good a good application from the Google Store, so to say, for your Android device. And the reason why I say that is that Android gives you a lot of playroom when it comes to the developers side of things. So if you ever notice how iOS is very structured, is pretty much cookie cutter based for every phone that you see. So if you know how to work a iPhone 4, you will have no problem with the 12 or 13. It's pretty much the same thing. Maybe some features that we may not know of, but it doesn't take much to figure them out and then actually, use them in your day-to-day activities. Whereas in the Android gives so much leeway and play for the developers to customize their applications as well as the OS, is that you can easily get something that may have a lot of vulnerabilities in it from the App Store. And that's to me, that's a downfall for Android, but I love the customization of it. But that's me being my own opinion. But in the enterprise, we want to make sure that we understand from a security standpoint that this customization to our applications and to our phones may pose a threat, right? And so we want to make sure that we have some type of software that can also, not only if we have Apple devices in our environment, that they can talk to Apple as well as Android as well, and making sure that we can push out those patches and making sure that we keep that management console around those devices. So, like I said, to reiterate what this control panel or this control system is going to do, we can put passwords in and we can customize the password to, are we gonna go 6 digits or 4 digits? Are we doing a pattern where we draw out a pattern with our finger? Are we doing passwords in a combination of PIN? So I think the latest one that I've seen is they want you to do numbers as well as letters for your login PIN. Now, biometrics is a good one to use, I believe, in my opinion, but it could be kind of scarce around individuals who don't want to use biometrics or don't want to have their face embedded, quote unquote, into the phone to have it memorized or to remember your face or fingerprint. So you may get some pushback on the biometrics, and you might have to rely on the PIN and the password in order for your users to use their devices. But it will behoove you to actually implement one of the other, if not two, in order to have a multi-factor when it comes to your mobile devices. So like I stated before, that kill switch, the remote wipe, having that feature is very good when it comes to having someone in your environment that travels a lot, uh, and they are keeping a business phone on them or a tablet, and they maybe, late night or late flight, and they leave their mobile device on a bus or on a plane. And so now, whenever they report back to you and say, hey, I lost my phone on the plane. What do we need to do? You can go ahead and go into your mobile management system and send out a remote wipe signal to that phone. And once that phone checks in with the antenna, or I'm sorry, the satellite, it will receive the command and then process the remote wipe process for that phone. And now, whenever someone gets it, they may have the phone and they may have something that's wiped and clean already, but at least they're not giving up any kind of business information, right? Sometimes you might want to put a full disk drive encryption on your mobile devices. So I think in the other class, I mentioned how we will want to encrypt the whole hard drive on your laptop, just to kind of ease our notion of any type of lost device. And then once it's lost, then let's say I lost it in a place where it cannot reach the satellite, and therefore it can't get the remote wiping signal in order to wipe. And so now it's just pretty much open. But if I have put a full encryption on it, then that person, whoever may seize it, they gotta know the key or the password in order to get past that first layer of defense in order to see the contents of the mobile device. Now, in the conjunction of having a remote wipe session or feature, you can have location services on there as well. So tracking the phone, tracking the tablet is also a good way of keeping up with it, seeing exactly where it did someone leave it there, or if it's out of the reach of whoever was responsible for it. So geolocation and then geofencing and geotagging will fall into this category, and that's basically putting a tracking device on that mobile device, making sure that it, once it talks to the satellites in space, right, it's talking to those satellites, it's getting a geographical location on it, and then reporting back to that management server that we are using to actually manage our mobile devices. So just keep in mind that you've seen this thing before. If you ever have used the Android and it says find my phone, more than likely it's sending out a Bluetooth signal to that phone to actually find it. That's kind of a low grade point of it, but a better example would be Find My iPhone for the Apple products, and that's going to have you log into a management type of a console, right? Your Apple ID, you use your Apple ID to log into your account, and then once you want to see where that iPhone is exactly what you see here on this slide, where it shows you a map and it shows you the geolocation of where your iPhone or iPad is at. So application management is important to understand what's the baseline of our phones. Do we want our users to put any type of application on their phone, or do we want to keep it to business only applications? And I think the first thing we want to do is just put that out in the policies first of what's accepted and then what we will not accept, because every application is not meant to be used on a business phone, in my opinion. So we want to set the baseline for it first, but then we want to use our management system to actually, if we want to roll back any type of add-on applications to it, or maybe restrict any type of download of unauthorized apps. So we want to make sure that we lay a baseline, and then we let our users know, hey, you can put bank applications on your phone, but we're going to refrain from using any kind of social media applications on our phones. And the reason why we want to do that is because, and especially for that actual scenario when it comes to not letting someone use social media applications on their phone, is because it comes down to content management, right? If we're able to look at different types of business emails on our phones and then mistakenly upload those things to a social media platform, then we are essentially leaking out information into the outside world, the public, right? That's what I'm trying to have you see when it comes to data loss, is that it's almost like an imaginary line around the business that I want you to think about. But the different ways that data can actually leave the business and go into the public size is many different ways. So it doesn't necessarily have to be through an email from the inside of the building to the outside. It could be a mishap. It could be someone taking a picture of the inside of your building and then posting it in LinkedIn. And now if I'm a hacker doing reconnaissance, I can just look at your profile and figure out, oh, okay, they have this type of doorway, they have this type of locks. I need to prepare myself in this type of manner, right? So that's what content management kind of goes into. Do we want to take that risk of having people leak out information intentionally or unintentionally. Another risk that we take into consideration when it comes to mobile devices is rooting and jailbreaking. It used to be a hot little thing to do when to get a Fire Stick, an Amazon Fire Stick, and then jailbreak it in order to get so many channels on it, right? Same thing goes for mobile devices or any kind of customization to the iOS platform, is that we take it and then we jailbreak it, quote unquote. And then now it unlocks this kind of a special feature set. But jailbreaking causes a vulnerability, right? It opens another doorway to the sensitive information that may be on the phone. So how do we take accountability of that? How do we prevent that type of action that be happen? Or can is it something that we just need to accept, and then we set our policies up to punish whenever if we ever find out that something does happen like that. So the next thing I want you guys to think about when it comes to mobile devices is, how do we actually connect, right? Are we using telephone connections? When I say telephone connections, I mean, are we using the actual phone carrier's connection in order to communicate on the network? And or are we using some type of Wi-Fi signal? So for those who don't know, those are two different networks that we could be connected to. So if we're just, let's say we're not using Wi-Fi for that point in time, and we're only using the AT&T bars, then that's a whole different network than versus if we're connected to the local Wi-Fi that we're in the building, right? Also, because not only could somebody be leaking or sniffing the network on the Wi-Fi side, you could see some type of leakage on the networking, the telephone company side as well. So we want to be mindful of that. We also want to be mindful of, if we're going to give our customers, our users, hotspots in order to connect. Maybe that might be a better secure way in order to transfer the data back and forth. It's not about transferring personal data. It's about the business data being on that phone or accessible on the phone. If that makes sense. Is not so much that I'm worried about who am I calling on my cell phone. It's the fact that I can open up a professional email and read sensitive documents on that phone or on that iPad. And now I'm connected to this game that I downloaded, but on the back end of that game, it allows remote users to go in and then look at the kernel or transfer or transverse through my phone to see what type of files I have opened or saved downloaded on the phone. Right. So that's the thing that I want you guys to really get when it comes to the importance of why even worry about mobile devices. Okay, so to go and finish this slide up, we're talking about connecting either Wi-Fi or cellular services, but also, do you want to give hotspots? Do we want to make sure that we put in another mobile device to create a network in order to have more control of what our users connect to? Because a lot of times our users go and they're not really looking for a secure way of connecting. They just want to connect because they have a certain job that they need to do in a certain amount of time, and maybe connecting to the local Starbucks is the closest and fastest thing that they can do. So we want to make sure that we take all those things into consideration when we have users that's on the go. So another way we could connect is through Bluetooth. And while Bluetooth will not give you the Wi-Fi connection type of network, but it can send information from one device to the next, right? And so we seen a lot of this when in the earlier days where we had PDAs and we could connect from one PDA to the next, and they can send traffic or let's say contacts back and forth. And you don't really see it nowadays that often because we kind of send it through the data plan or the actual network. But back in the day, you would just get close to the actual mobile device, and then it will actually jump over. We see a lot of that now with the NFC near field communication feature with tap to pay, or you go up to the register, and then you put your phone to the register keypad, and it pays for whatever item that you want to pay for. But nevertheless, Bluetooth connections can be vulnerabilities as well, right? Being able to know that it's on, and it's listening for whatever communication signal out there that wants to talk to it. And then in certain cases where you don't need a pin to actually connect, that device can actually connect to it and then start communicating back and forth. We see a lot of that with headphones. Headphones, they will turn on the Bluetooth, and then it's waiting for any person to connect to it, and it will connect to it and then start communicating back and forth. Whereas in your laptop automatically probably has Bluetooth on, and it's waiting for someone to put in a pin in order to pair it. Same thing goes for your car. But we want to make sure that our customers, our clients, they are aware that Bluetooth can bring some risk, and for the most part, we want to make sure that Bluetooth is turned off if not needed, right? So we want to make sure that we want to stay away from things like bluejacking or blue snarfing, where people can send unsolicited information to your phone or tablets, or take things from it in the case of blue snarfing. To kind of piggyback off of Bluetooth and going into infrared and RFID, sorry, is kind of having these close interaction with people, and being able to pull off their information just by having that radio frequency ID, pull that information off. So a lot of times you'll see, if you look on TV, you'll see a commercial where they're promoting a wallet that has a radio frequency ID blocker on it. It has some type of magnet on it, right, to stop that communication field from actually happening. And what would happen in the attack is that if they show on TV, they will show somebody sitting on the same bench as you in a park, and while they're not doing anything towards you, they're close enough now to where their phone or whatever device they have can pull the information from your wallet. So it's pulling the information off of your credit cards and debit cards, and then now they have that information. They can go in. You've just been basically robbed, right? So in order to stop that type of attacks, people will put in these magnets that breaks up that communication field. So we want to make sure that we are aware that it happens. I personally haven't seen it happen, but hey, it might have happened and no one told me. So just make sure that you understand that type of attacks does happen, and it's pretty much getting into a personal space with someone, and then now that communication field has become open, and you can actually transfer data that way. Now, I brought this up earlier in the slides with near field communications, that NFC. Uh, Now, it's not such a bad thing, right? In order to use this type of communication, it just can be used in the wrong way. But it's also becoming a more convenient way for people to pay for different items. So you see this communication becoming more prevalent in places like gas stations and gas pumps, where you could just point your phone or your card up to the device, and then it there's no swiping, there's no inserting the card and then pulling it out. It's simultaneously communicating back and forth the information that's needed in order to pay for the service. Another connection that we have when it comes to our mobile devices is just plain old USB connections. And sometimes we like to plug in our phones to our laptops just to kind of charge them up throughout the day, especially in a business setting. But it's also a way that we can transfer data from one device to the next, right? So if, let's say, if I'm plugging up my business phone to my personal laptop, and my personal laptop is affected, well, guess what? I just open up another gateway into our business without me really knowing it, right? So as you could tell, there's so many ways that our data could actually just be leaked out without people really kind of taking it into accountability, or really, they could be wanting to do the right thing. It's just convenient wise, it was convenient to plug into your laptop at that time, but um, if you didn't know that your laptop was vulnerable at that point in time, and maybe had someone, it was part of a botnet, and now is going into the business side of things with your company, now we can pull that information, and it just creates a whole big mess, right? So how do we fight the USB connection, and data transfer without our permissions? Is 9 times out of 10 we're probably going to write some type of policy, group policy, to shut down our USB ports. And when I mean shut down, meaning we want to not have them communicate or mount the device onto the hard drive. We want them to maybe power the device, give it a charge, but it doesn't open up that gateway to actually communicate back and forth. So we want to make sure that is in a disabled, and but yet, in order to charge, make sure that's enabled. We also want to be aware of SMS type of notifications. So any kind of text that's coming in, or any kind of notification that's pushed to our phones, make sure your users are aware of what type of notification that may come from your business, and then what may be spam or some type of phishing type of campaign that comes in from a text form, right? So we want to use we can use SMS for helpful things, like adding another factor of authentication when it comes to logging in, saying, hey, we logged in with our username and password, but now the server sends us a notification on our phone, says, hey, we're going to give you a code on your computer screen. You may see something for you to type in a code. Type this code in. That way it's used in a good way, because if you don't have that phone, then I can't. 9 times out of 10, I'm gonna say, hey, my user will have their phone on them. So in order to know that this is you using this username and password, I'm gonna send this to your phone, because you should have that too. And then now plug that in. Now you authenticated. I trust that this is you, right? But at the same time, it could be something used in a bad situation, where I'm sending you a link in a text message, and I'm asking you, hey, would you take a look at this file that the finance department shipped over, and it's from a random number or a random person, and you don't know anything about it, but they use the terminology that you're working with. So you click on it, and now you open up that gateway to someone else to actually go in there and see what's going on. So overall, we want to make sure that we have our mobile devices patched as much as possible to ward us away from any type of vulnerabilities that may be on our mobile devices. Just like how we want to take care of our PCs and our laptops and servers, we want to take that same approach when it comes to the firmware on our actual phones. When Android and Apple say that, hey, we have updates ready, it's for security reasons, and for functionality as well. You may get a little bit more of a functionality standpoint, so Apple may give you some new emojis, but if you really read what's going on when it comes to the updates, they're saying, hey, this update is to provide more security to the phone, basically. So just make sure that your users are updating their phones, making sure that they are connecting to a Wi-Fi connection, and pulling in all those over-the-air updates and updating those firmware. So the same thing goes for your mobile cars, right? Your actual Teslas and your new high-speed car. That's it takes an over-the-air update, you might want to connect it to your home Wi-Fi in order to receive such a big package like that, and then now apply it to the car firmware. So in this lesson, we went over several things that can help you out when it comes to your mobile devices and the management of them. We want to make sure that we give our functionality to our customers, our users, and making sure that they can do their job efficiently. But at the same time, have them understand that these are just small computers that they have in their hands, and that they can open up other gateways for people to come in and actually see uh, business data on those phones, those tablets. So making sure that we have the proper management system for them, and that they're up to date, putting in the proper policies to making sure that we have the applications that we want on our machines, and that our users know how to properly manage them under their care. So let's get into lesson 14. This is securing application concepts. We're going to talk about different types of web application attacks that we may encounter, and how do we put things in place to ease that pain if ever faced with that challenge. So when it comes to your applications, you want to make sure that you have proper coding whenever you're working in an environment where you have a department actually creating an application. You want them to actually use proper coding. And in order to do that is pretty much based on validation of the code. So whenever someone writes the code, you want someone else backing them up to read that code and validate that it is proper code, and that you take any kind of mistakes out of it. So we want to make sure of that, but we also want to make sure when give it permissions to let's say like a third-party application where we don't know the source code to that application, we want to make sure that they don't have more permissions that's needed in order to run the application, because hackers, what one of their traits is looking to have more permissions than actually needed. And so if I have more permissions, then I can manipulate and have the application do what I want it to do, because I have the permission to do so. Now, when we're talking about developing an application in-house, we're talking about building code. And like I said before, we want that input validation. We want to make sure that code is actually validated by someone else who did not write the code. This way we could prevent things like buffer overflow, where we have we want a set number of characters to only go in to our, let's say, field, our username field, right? To give the example that you see here on the screen, is that you have a set number, but let's say the hacker says, hey, I'm going to put some extra characters in there to see if it sends a error code to the database, and therefore spills out the information that I would like to see in a memory bank somewhere. So this is how you get kind of like a memory leak, where it leaks out information because the server doesn't know how to deal with the extra characters that's put in. It's so we need a buffer there to actually say, hey, this is the capacity, this is the limit of what you can actually put in. So if let's say for most usernames, it's between 8 to 12 characters. And let's say I put in, but let's say there's no buffer, and I put in a whole script of code into that username box. Well, it may send an error there, because remember, servers are there to actually try to figure things out and understand what you're trying to do. It's listening for a command and then trying to give you the results. And so hopefully if I put all of that script into that username box, it may kick back some information that I wanted, such as give me all the usernames and account numbers that's in your database. Okay. And we want to look out for DLL injections as well. This is where it's kind of like when I was just explaining with the buffer overflow, that server is looking to give you some type of answer because you requested something from it. And that's the way we need to look at servers. Servers are there to actually serve you in some type of way. They're trying to give you some type of service. Well, a DLL is some extra functionality to that application that's trying to give you some extra function that makes your life easier when it comes to using the application. The first thing that comes to my mind is maybe like when you're using a calendar, it will give you the calendar for the next, I don't know, 25 years, right? So that extra functionality on, let's say, the application being Microsoft Outlook, well, that DLL driver that's sitting in the background of the application is built only to get that information from the server to say, hey, I want the next 25 years of calendar months, and we're going to store them until the user is ready to see them. But if I manipulate that DLL, whenever it calls out, I can have it call out to a rogue server and then have it deliver malicious software to your machine instead of those functions that it was built for. Have that same mindset when it comes to APIs too, application programming interface. That same mindset of someone taking advantage of the extra functionality that you want to have between two applications. So we're going to use the API for these two applications that normally wouldn't talk to each other. We're going to have them talk. Imagine if someone were to manipulate that line of communication. Now it can be redirected to their will. But we can eliminate this or reduce the risk of it by having some type of input validation. Again, this is having someone look at the code after it's written. That input validation part is going to show up again and again on the test. So just be aware of it. Now let's talk about replay attacks. Replay attacks is taking tokens or cookies that we have accumulated with our web browsing and then taking those cookies or session keys and then replaying it back to restart the session again. And then if I'm a hacker, then I'm going to manipulate whatever I want to after that. So if I go to a spot, let's say my banking account, and they give me a session key in order for me to do some transactions, but then I'm compromised in a way and the hacker sees my session key. Hopefully it had a time to live on it, which is a TTL, and that normally cuts the session off at a certain amount of time. But sometimes you could take those session keys and put them back into a browser and it still has your account open. For example, if have you ever been browsing on the internet and you close out the window, but then you close out the window, let's say to Facebook, but then you still have the actual Chrome window browser open, and you still open another tab in your session for your Facebook account is still logged in and actively running. So those are kind of just ways of seeing how your session can actually live without it being timed out, automatically going to a log out state. So we want to make sure that if we're building our own applications, we put those things in. How long should we be idle before we actually kill that session key? Or should we be taking cookies from our users and keeping them for data purposes? So these are things that we want to keep in mind when building our applications. We also want to be aware of these session hijacking and the cross-site request forgery. And this is where we are encountered by a link from the attacker that redirects us in some type of way or fashion or form. The main thing that we want to remember here is to teach our clients not to trust everything that we see when receiving emails or links in chats or links that are sent to you via the text. Sometimes links are very hard to read, and then even if they're easy to read, sometimes just one character can throw you to a whole different type of server somewhere that you didn't want to go. And sometimes these servers can give a front web page that looks promising. It looks like it's no harm to it, but you don't know what they're taking from you on the back end. We also want to watch out for cross-site scripting, and that's where a malicious hacker takes a script and embeds it on a legit website, and maybe the website owner doesn't know that that malicious script is on there, but it's there as a gateway to their malicious site, right? Or to gain some kind of access from your PC. So we want to make sure that we are aware of that. As security professionals, I put here on the second bullet, you can see that csi.forcepoint.com, we can go there and actually plug in the website that we are weary of, or just to check to see if they are any type of malicious links on there, and then we can warn our clients or whoever, hey, we might want to avoid that website until the owner fixes those issues that's on their site. Now, SQL attacks, I should have had this SQL attack slide right behind the buffer overflow slide, but it is pretty much how I like to group those things together. Is the SQL attack is normally how I look at a buffer overflow. I'm going to plug something into the username that's a SQL injection, and thinking that since SQL is probably going to have some type of if I'm using a username and password, I'll probably have some database of all users that's using this platform that I got, and they probably have some passwords to them or an account associated with them. So if I could put in a query attack for that, then hopefully the server will give me back all the names that's here in the database. So that's what I like to do when I'm thinking about a SQL injection attack. Is more of giving a command to a SQL database and then telling them to give me all of the information that's within the server. Along with SQL injections, we also have XML and LDAP injections. And all of these injections are pretty much going around the same route, right? I'm interjecting something that wasn't supposed to be there in the beginning, and I want something from it. That's why a hacker is going to come at it at that standpoint. And again, it all goes back down to input validation, making sure that we avoid things like this, because we can avoid it in the beginning of building it. And if we've skipped that part, and then now we pushed our application out real fast, when that vulnerability shows itself, we need to then make a revision to it, and then that's how you get application upgrade, that 2.0, because we needed to fix this issue, this XML issue that we had. And you don't want to take away that functionality or give so many revisions out so short of and so many short of a time, because it takes away from your customer's experience, right? So we just want to make sure when building an application, we want to make sure that we have the right people looking at the code and validating each other. Now, as a security professional, it's always good to give guidance when it comes to building an application in a corporate environment. So we want to take our people who are using code to build our applications. We want to make sure that they use the OAuth's website in order to see best practices on when writing code, or what's the top 10 vulnerabilities that we face when it comes to web applications. So this is a good way we can point them in the right direction, so we can build our applications right the first time, and hopefully just make small revisions and not necessarily really big ones on a regular basis. So how should you handle your cookies when browsing on the internet? You want to make sure that we have cookies for the convenience of it, but we also want to make sure that we are not using the persistent, having our cookies be so persistent to where we never clean them out. Meaning, for example, for me, I use the cookies just so I can stay logged in to ESPN and I can play my fantasy sports, right? And I don't like to log into ESPN just to get to that profile to play my fantasy sports. So I keep the cookies there to keep that session going. But I have to keep in mind that I have cookies that's for other sites as well that's keeping me logged in to those accounts. And so I will say on a maybe 2 to 3 months, I clear out my cookies, I clear out the browsing history, and I make sure that I start back over, because you don't want to get into a point where if you are compromised and someone is snooping around on your PC, that they can look into your cookies and then find out where you've been, and then actually see if there's some sessions automatically authenticated in there. And so now you have, basically let them into an account that they really may have been looking for, but they're glad that it's always been open because you kept the cookies on your web browsing history. So I talked a lot about, in-house applications. If we're building it, then we're going to use input validation to actually look at the code, have someone else look at the code, maybe even have someone else look at the code. But let's say if we're using third-party applications. Let's say if we bought the application and now we're going to put it in-house. The main thing that we want to make sure in that situation is that we make sure that they don't have any vulnerabilities that's out there. And make sure if they do, that we have the patches ready to go for that application. We may need to put it in a test environment, see how it works, see if it still works with everything else that's in our environment, and then push it out to the mass. But we want to make sure that we understand that there's no vulnerabilities coming from our outside into our environment now. So just make sure that you understand that when bringing in others applications, because when you're bringing in a third-party application, more than likely you're not able to see that code that they're using to make it. They're going to give you a finished product, and whatever the application does, it does. And you're not able to go in and see the source code and actually change it to customize it to your ability. Not all of them do that, but majority of them that you would come in counter with are going to have some type of block on it. So just make sure that they don't have any type of known vulnerabilities that we know that you know of, and then if they do, making sure that you have the patches ready to roll out. You can also use some type of coding practice where we're using obfuscation on, and this is kind of like a big word for it, but another word for it is just using camouflage. And a good example is what you see a lot of times when it comes to passwords. When you're typing in your passwords, you're getting these little stars or you get dots instead of actual letters of what you're seeing. But now, for convenience purposes, they have the little I that's at the end of the password block, and you can hit that and you can see what you typed in. Because I get it, once you start typing in 14 characters, it's kind of hard to remember if you hit the A or did you hit a P. So I get it, but you can have that obfuscation there to hide things in front of people and make things secure, without being so secretive. Now, when we're building our own applications, we want to make sure we test it and test it and test it before we actually send it out to what we call production, when we are putting it into play for others to use, our clients to use, maybe our coworkers to use. When we're building an application, we want to make sure that that application team is testing it, putting it against stress testing, and making sure that they may run some type of let's say they do a buffer flow over attack on it, and let's say they do a SQL injection attack on it. See how it actually reacts when it comes to putting those attacks onto the application. How would it react? Will it give out information? Is it something that we need to actually change before we put it into production? Because once we put it into production, now, like I said, if we find out later that it does something that we don't like, we need to roll out another revision of it or update to it. Right. So we want to make sure we do all these the fuzzing and these stress tests beforehand before we actually push it out to the public. Now, in a corporate environment, when we're rolling out a application, we want to make sure we have a process, some type of plan in order to deploy the application. But at the same time, we want to make sure that we have a process of removing whatever application is coming in to replace. If it's coming in to replace something, we want to have a process of removing applications that we're not using anymore. And we all know why, because if we're going to say, hey, we got the new latest and greatest of what we need. We don't need the old. And if we're just going to keep the old on the PC, now we're just leaving something to be a risk factor later on. It could be manipulated by someone else because we're not using it. So it's best for us to just take it off the PC and dispose of it that way. But we also, going back to deploying the new application, we need to understand that we need a rollback plan just in case something happens, or the rollout didn't go as planned, or someone turned off their PC that night and now they couldn't receive the application over the internet. So we need to have this a plan in place to actually push the application, take away the old application, and then have some type of review of what we can do when it comes to how do we do it better. Now, when it comes to the version control, we also want to make sure for the third parties, for third-party applications that we bring into the company, we want to make sure that we're probably one version behind the bleeding edge of what they're putting out. To give an example, is that if I'm Microsoft and I want Microsoft Office, and Microsoft Office is on version 16, I want, as a business, I want to be on version 14 at least, because or version 15. The reason why I want to be on version 15 at least is because I'm not willing to see if there's any issues with 16, and I know 15 has already had a limit, so to say, right, of vulnerabilities and things that they have made. So I'm going to stay with 15, make sure that it's patched up as much as possible, and then have 16 in a test bubble. So whenever they move to 17, I can then roll out version 16. Now let's talk about software diversity. Now this is having some type of obfuscation when it comes to the different types of software that you have in your environment. You don't want to make everything so Microsoft driven or Cisco driven. We don't want to be a Apple shop all together. Like, we want to have bits and pieces of it. The reason why is because when you are just one shop, let's say if everybody's a Cisco is on Cisco devices, and then Cisco comes out, the company comes out and says, hey, all of our devices are vulnerable to remote coding and remote coding vulnerability, and it's a very critical vulnerability, and for right now we don't have an answer for it. Now everybody in the shop is pretty much vulnerable to this attack. In turn, it brings a big risk to you having to stop operations because you are vulnerable to this vulnerability. The one that comes to mind when it comes to an example is SolarWinds. SolarWinds just had a big vulnerability to where it pretty much crippled the applications across the board. Well, you had a lot of companies that would get that whole stack, because not only SolarWinds will offer some type of network appliance or device, they would also offer a application for help desk, or they may offer some other application for logging and SIM activities. So across the board, across that whole stack of applications, now you can't really do anything because all of this, all of the applications associated with them are vulnerable. So we want to make sure that we have a good diversity of vendors in our environment. We want to make sure that we're not all using the same products, but they work well together. We want that. We want things that work well together, but not necessarily made by the same company. And that gives a good diversity and a good security measure when coming into the when a hacker comes into your network. To give an example of that is that if a hacker comes into the network and they're very good at PCs, but then they jump the network and now they're on a Mac PC or a MacBook, I'm sorry, and they don't really learn Linux like that. So now it creates a defense in depth again by having something that someone is maybe not be familiar with. All right, just by having that diversity. So the key points to review when it comes to application building, remember the most important thing that I want you to take away from this lesson is input validation. If we're building the code, I want someone to build it, but I also want someone to check it, maybe even double check it. All right. Now we went over different types of attacks that could happen when it comes to coding, and we also went over some type of remediations that we could put in place when it comes to the attacks that go against our different applications. So lesson 15, let's go over implementing secure cloud solutions. We're going to go over the different types of deployments. We're going to go over different types of services that you can get in the cloud. And then we're going to go over how we should carry ourselves when putting things into the cloud, and how do we scan for different things when they're going back and forth from our local environment to the cloud environment. So there are three cloud deployment models, and we're going to go with public, private, and then hybrid. And with the public means that anybody can use it, whether you're a business or you're a private entity, or you're just a community service group. Anyone can use this public deployment model when it comes to the cloud. The one that comes to mind is AWS or Google, like Google Drive, or you want to think of a Microsoft account. Those are public domains when it comes to the cloud. Now you have private, where it's just like that's your own section of the cloud. So no one else is going to be able to be on the same server that you're on. No one will, if you're not, you pretty much bought out that section of the cloud for your own personal or business use. Then you have community. Now, community or some type of hybrid, I'm sorry, some type of community means that we're doing the same thing. We're in the same industry. So I like to think of it in a medical sense. Where you may have a big hospital that needs to put information into the cloud, but you also may have a small dentist office that want to put things in the cloud. Since we're in the same medical field and we deal with the same type of data, 9 times out of 10, we're probably can get together and get into a cloud deployment in that community section. So now let's talk about the cloud services models that you're normally going to see when it comes to buying some type of service off a cloud provider. You're going to see infrastructure as a service, IaaS, software as a service, SaaS, or platform as a service, PaaS. And we also are kind of getting into the anything as a service, that's XaaS. And let's start off with infrastructure as a service. Infrastructure as a service is pretty much they give you the bare bones of a cloud environment. So they're going to give you maybe an operating system, and you're going to have to build everything from there on out. So they may not even give you the operating system. They may just give you storage and a interface in order to connect to it, to the cloud platform. And now you have to go up there and set up your networking. You need to set up what type of servers that you want to use, install the servers, configure the servers. You're building everything from scratch. So I want you to think about, whenever you see infrastructure, it is the most work that needs to be done in order to get a finished product. You're talking about someone who can go to the grocery store and buy raw materials and make things from scratch. All right, not just buying something that's already pre-made and then warming it up. That's more in these other models that we're going to get to. So infrastructure as a service is bare bones. You're building everything from the ground up. That's the easiest way I can put it. So software as a service is Well, let's skip software as a service and let's go to platform as a service, and then we'll go to software. So platform as a service is you already have a pre-configured OS, and it's going to be sitting there waiting for any type of configurations or special applications to go on there, and now you build it from that standpoint. But like I said, infrastructure, they won't even give you the OS. They'll just give you basically a box. All right, if you want to think about it like that, a empty server, and they say, here you go, and it just have the bare bone minimums. But the platform, at least it will give you a baseline, some type of OS that you want to build upon, and it has that infrastructure already configured in it. So you'll have the networking, the CPUs, the memory. You'll have all those things allocated, and you'll have a OS to work upon building your application or building however you want to build your database on top of that. Now, software as a service, they're going to only offer you the application pretty much, and these are ready to go, and you have less work to actually configure. Um, it's going to be pretty much, these are the layouts. You don't really get too much of a configuration or customization to your company. So a good way of thinking about this is things that we already use on a everyday basis. So if you have an email account with Yahoo, Gmail, or Hotmail or whatever, those are software as a services. They're already pre-configured for you, and you just pretty much log in and you use them. Another one will be any type of Dropbox, Google Drive. These are software as a service type platforms where you log in, and now you can change like who can see whatever, but you can't see no code. You can't take the application off and see what's running the application behind the scenes. So you can't see that OS behind the scenes that's running the OS. I mean the application. You could just see the service that you're seeing, right? And those are the most ready to go out of the box. We can use it within a matter of days of configurations, where platform as a service and infrastructure as a service may take, you know, to weeks to months before they're actually ready to be put into production. Now, when we thinking about what the cloud is, we need to go back to what a hypervisor is and how it actually runs. So we have two types of hypervisors, and type one will be a bare metal hypervisor, and that's where the OS is going to sit on top of the bare metal, and it's going to run the virtual machines off of that bare metal instance. Okay, that will be the picture off to the lower right hand corner, and that's where you're going to see different types of VMs coming off of the hypervisor software that's there. Now, a type two hypervisor will be something more where you have a hardware, but then it has a operating system already installed on it, and then we actually go in there and allocate some of the hard drive and memory space that's allocated to that's given by the OS, and we can actually spin up virtual machines off of that. That's where you see where things like VirtualBox come into play, or um, oh Jesus, VMware platforms come into play, where you actually download it on your personal PC, but then you can spin up a Mac OS on a Windows platform on your personal machine. So that's type 2 hypervisors. When we're talking about the cloud and these cloud providers, we're more likely going to be talking about a type 1 hypervisor. They're going to be giving, they have data centers that are type 1 hypervisors, bare metal, and they have the hypervisor software spinning up different types of virtual machines for the consumers. Now, when we're talking about having security controls on the cloud, we want to make sure that we follow the same format that we do when it comes to physical devices that we have in our environment. So we want to put endpoint protection on there. We want to make sure that we have policies out there regulating what users can do and what they shouldn't do. We also want to make sure that our firewalls and our logging systems are actually seeing the traffic and logging the traffic, maybe preventing the traffic that's going to our cloud provider, and making sure we watch that traffic from our users to the cloud provider. So making sure we have all these things in place will keep our data secure, but at the same time keep our internal networks secure as well. Because not only is the cloud out there for anyone to get onto. Remember, we can have a public instance to where we are sharing the cloud instance with a lot of folks. So say if one cloud provider gets compromised, but yet you're sending data that way, if they're compromised, then your data that you put onto that server, their cloud instance, could be potentially vulnerable as well. So just keep those things in mind, making sure that we keep all our policies and our endpoint protections up to date, and making sure that we watch that traffic going back and forth. We want to make sure that we are aware about how much power we want to pull from the cloud environment. So the reason why the cloud is so popular is because of its elasticity, resiliency, being able to expand, contract at a very short time. Given the fact from which we came from of buying RAM or buying storage and then waiting for delivery dates, we can have changes to our environment in a matter of minutes. So you want to be aware of the type of CPU and RAM storage that you get on your cloud instance. You want to make sure that you have something that's allocated within your budget. Let's say that you don't want to overkill something that doesn't. You don't need that much power. You don't need that much storage. So just make sure that you have something that works into your favor, and you don't have to really worry about having too much or too little worth of power. Now, with that power comes availability too. A wonderful thing about the cloud is that it seems to never be down, right? And a lot of these cloud providers, they have databases scattered throughout the globe, and they're all connected to where if one were to have a maintenance day or even a natural disaster, then they can easily route traffic to another point, and you as a consumer really never see it go down or is not available. So having that uptime, having that availability standpoint is such a real attractive point to businesses, because where if we're having all our data in one spot here in let's say Tennessee, and then a hurricane comes and makes it to Tennessee, one makes it to Tennessee and then destroys that data center, um, then now we have to pretty much suspend business until we get that data center back up and running, and that could take months to years, right? So having a cloud instance back that data up or make that data available at any given time is something that we want to look into, and making sure that we have the proper cloud provider in place in order to make our data available. Now, when you're talking about the network section of the cloud, we want to make sure that we focus more on private networking and separations of the networks. We making sure that we do a logical aspect when thinking about how we actually divvying out our IP addresses when it comes to the cloud, making sure that we're not just lumping everybody into the same mixture. We want to do it like we do a physical building. The marketing department has a set number of addresses, and the legal team has a set number of addresses, IP addresses. So we want to do the same thing when it comes to our cloud environment, separate these IPs out, And we also, if we can do NAT gateways and as well as putting VPNs out there, let's take advantage of those things because, like I said, the cloud is not necessarily such a new type of technology. Is more popularized nowadays, but um, it's the same concept of what we've been doing in physical locations. It's just now we're using the internet to have our data pushed to a data center that may be outside of our state or country for that matter. And now we just want to make sure that we treat that as a kind of a distance operation center. You want to be mindful of your security groups when you're talking about giving people access to your um, cloud instance. So we want to make sure that if we're building any type of identity or usernames or any type of users in the cloud, we want to make sure that we follow our best practices and give them only the enough permissions to do the job, and making sure that we follow the directions of if someone leaves, then we take away permissions from our cloud instances as well, because we don't want to just think about our Active Directory software that's physically in the building. We also want to make sure that the username and password that they use to log on to the cloud instance is also disabled whenever they leave the company. And sometimes it can be lost within the whole concept of working. But we need to, as security professionals, be aware of that and have that in our plans and steps to make sure that the identity access and management part of it stays true. Now, when we're talking about moving data from your local machine out to the cloud provider, we want to have something that's kind of scanning those documents or data and making sure that it's not leaking any type of sensitive information. So this is where CASB will come into play. CASB stands for Cloud Access Security Broker, and it's going to sit as an agent on your local device, and it's going to look at your user putting information out to the internet or to a cloud provider, right? So whenever, because here's the thing, you don't, while as security professionals in our work environment, we may have a set number of cloud providers that we work with, but that's not necessarily who all your users work with. So to give an example of that, the security team may say, hey, you can use box.com and Dropbox for your storage outside to a cloud provider, but you may have users putting things in OneDrive, Microsoft OneDrive or Google, and putting it in their Google Drive. And we're not aware of it because we allow everything to go out to Google. So we want them to go in and search on Google and maybe look at their email on Google, right? Well, Google also offers all of those different applications, which is, cloud based. So we want something like a CASB sitting on our PC to scan those documents going to other cloud providers that we may not be aware of that our users may be using. So in this lesson, we went over the different types of cloud deployments, the different types of services that you can have, and we also went over different types of security measures that we need to put in place in order to teach our users